Hello again and welcome to my home studio, which is actually my ironing board right now. So this is the second lesson that you'll be doing at home this week about the weather unit. So today's topic is called atmospheric pressure. Again, this is getting into grade 11 chemistry. We have a whole unit on the atmosphere, and we have a unit where we talk about pressure. And we learn about the different units there are about pressure and explain them in a lot more detail next year if you take grade 11 chemistry. So the first definition is something called atmospheric pressure. Again, if you take grade 11 chemistry, we go through it in a lot more detail, slowly and carefully. We're just giving you the basics in grade 10 science. So our definition for atmospheric pressure, it's the pressure exerted by the mass of air above any point on the Earth's surface. Now, in terms of units, like I said, grade 11 chemistry, we learned 5 different units of pressure we can use and what they mean and when we use them. But for this unit, we're going to, quite often you'll see kilopascals. I think when we look at weather reports, especially in Manitoba, most of the weather reports talk about pressure using the unit of kilopascals. Well, that's based on the Pascal, which is the SI, System International. That's basically our metric system. We use Pascal as the unit of pressure in our metric system, but we use kilopascals because Pascal is such a small unit. So when you see kPAs on your weather report, the whole point of this is that when we do weather reports, they report pressure in a unit using kilopascals. Like I said, take grade 11 chemistry to get to the full story. Okay, so that's what atmospheric pressure is. So what are some things that affect atmospheric pressure? One is altitude. So this one I think should be pretty straightforward. As you go higher up, the higher the altitude, the lower the pressure. The lower the altitude, the higher the pressure. And that makes sense, even if you haven't taken grade 11 chemistry yet. The higher up you go, there's fewer air molecules, gas particles, and they're more spread out. So if they're more spread out, they're less dense. The less dense they are, the less pressure there is. So that's why you see higher altitude has a lower pressure because there's less air above you, and then lower down, there's a higher pressure, there is more air above you. So I think that one's pretty straightforward with the altitude. Now, temperature. Again, this is getting into grade 11 chemistry. How does temperature affect pressure? Well, when you have a higher temperature, that's going to cause the gas particles to move faster. And as they move faster, they're going to move further apart. Again, same reason. When they're further apart, they're less dense. So if they're less dense, that means there's less pressure. So a higher temperature gives you a lower atmospheric pressure. At cold air, and then the opposite would be true. Colder air, the particles are moving slower, so they're coming closer together, they're more dense. So if they're more dense, it's a higher pressure. So higher temperature, lower pressure, lower temperature, higher pressure. And then we talked about this in our last lesson about warm air being less dense, cool air being more dense. So that's continuation from yesterday. Okay, this also is continuation from our last lesson. So when the warm air is pushed into an area of cold air near the ground, the atmospheric pressure in that location will decrease, right? We just said on the other slide, warm air has a lower pressure. So if a warm air pushes itself into a new area, it will decrease the pressure. The opposite is true. We said that cold air has a higher pressure. So when a cold air pushes its way into an area of warm air, it's going to increase it. So basically, if you listen to the news or watch weather reports, when they report the weather, it's more so the change in pressure that we're concerned about. It's not necessarily the pressure. Is the pressure rising or is it decreasing? And that's an indication, is there warm air or cool air coming? Humidity. So our third one is humidity. So a definition of humidity is how much water vapor is there in the air. So the more water vapor you have in the air, the lighter the air would be. Well, why would that be? So here's our little scientific definition. So as water vapor moves in the atmosphere, it pushes out an equal volume of dry air. Now we talk about dry air, we're talking about the gases nitrogen and oxygen. If you take grade 11 chemistry, like I said, you do study the composition of the atmosphere. This year we studied the layers of the atmosphere. Next year we'll study the composition of it. So water vapor would push out the dry air, which is heavier. So humid, wet air will exert less atmospheric pressure than dry air. So this is what our diagram says. Warmer temperature increases the amount of water vapor, and then more water vapor in the air increases humidity level. And then here it says the opposite. If you can see on this side, the cooler temperatures decrease the amount of water vapor, and then lower water vapor decreases humidity level. And then you see the term relative humidity. So the relative humidity just compares how much water vapor is in the air compared to how much water vapor it could hold if it was saturated. So if we say something has 50% relative humidity, we say that it is 50% saturated. So when the temperature drops, the relative humidity goes up, so there's more of a chance of precipitation. So like I said, when we watch the weather, people love to talk about weather. They also love to complain about the weather. Well, the predictions were wrong, and how did they get that wrong? It's a complicated science. There's a lot of chemistry and physics involved. And like I said, they do the best they can, but there's a lot of science that goes behind trying to predict the weather. And as the air temperature increases, it can hold more water vapor. Then our next term is something called dew point. The dew point is the temperature at which air is saturated with water vapor. So if something's saturated with water vapor, it's full. Now, as that water condenses, it will eventually fall out as precipitation. Well, how and when? When does it change from water vapor, condense back into rain? Well, once it hits the dew point. I like this diagram. I think it's a good visual. So the warm air is saturated, and then as it cools, it eventually will condense, and that's when the water vapor changes into condensation, which is rain, and that transition would happen at the dew point. So here's a weather forecast. It is from last year when I taught this unit. I didn't update it with our current weather. That's coming on the next slide. So on May 24th, 2020, the temperature in Winnipeg was 17 degrees Celsius. And then look at everything they talk about. They tell you the temperature, then they talk about the pressure, but they don't just mention the pressure. There's always, kPa, kilopascals. There's going to be an arrow. So the key thing, if the arrow goes down, that means the pressure is decreasing. If the arrow goes up, it's increasing. So they don't just state the pressure, it's the pressure change. Is it dropping or rising? That's the indication of what's to come. The dew point last year was 8.5 degrees Celsius. So that's the temperature at which it would transition. They talk about the visibility. Oh, and look, the humidity was 55%. And that was at 6 o'clock last year, May 24th. And the conditions were taken from the airport. Okay, so we talked about predicting weather. Okay, so we all like to talk about the weather, complain about the weather, complain about when the predictions are off, but it's a hard science. So how do they even try and predict weather? Like we said, it's the change in atmospheric pressure that they use. So when you get a drop in atmospheric pressure, that suggests usually that the warm, humid air is approaching and that the temperature will increase. And then that tends to lead to storms and unsettled pressure. Then the opposite is true. When you get an increase in pressure, that suggests that cold, dry weather is on the way, and that would be calmer weather. So I checked it. This is actually, today is, oh gosh, what is the date? Thursday, May 20th? Who knows the date anymore? So I know you're not going to see this video until May 3rd, probably June 1st or June 3rd. So it'll be a couple weeks away. But today is Thursday, May 20th. And if you think back to the weather, we just came off of a couple of days of hot weather, like full sun, 30 degrees, really hot weather. Now the rain started, and it looks like the prediction it's supposed to rain for the next 4 or 5 days. Well, I just took the weather. Just before I made this video, I updated it. Oh, it doesn't say the time. So the temperature today, it's 10 degrees Celsius, and it's raining right now. Now look at all the things they talk about. The wind, it's 76% humidity. The visibility, oh, that's the sunrise, sunset, wind gusts. This is the key one, pressure. It's 101.5 kilopascals, but look, there's that arrow going down. So the pressure is dropping. And what did we say? When you get a drop in pressure, that means that you're predicting storms and unsettled pressure. Yeah, that's what's happened. There was a thunderstorm last night. It's raining all day, and basically the next 3 or 4 days, the prediction is thunderstorms and rain. So yeah, that matches up. So when you listen to the weather reports, that's the key term, that pressure. Is that pressure rising or dropping? Oh, this afternoon, rain. Tonight, rain. The next day, rain. So that is consistent with what we talked about. Okay, so like I said, I know there's a lot of information and we're getting into some higher levels chemistry here, but that's okay. Your textbook assignment should be pretty straightforward. So page 284, number 7 and 8, and then page 289, number 7, 8, 9. And our funny joke for today is the weather forecast. So what's the forecast? Tuesday, pretty sure it's going to be sunny. Wednesday, iffy. Thursday, not a clue. Friday, wild guess. Saturday, question mark. And even though we've come a long way in science, there is limitations on predicting weather. So yeah, the long-term forecast can change and usually does. So give your weather people a break. Don't be too harsh. Don't complain about it. And let's learn about the science behind it. Okay, have a good day and enjoy the weather. Oh, I'm waving. You can't see. I'm off screen. Bye.